So at least part of what we're doing for Learning Target 5.4 are things that you've done in the past. We're going to be using statistics to compare center and spread of two different data sets. So the measures of center that you've used in the past are the mean, the median, and the mode. And you should be used to those. What you may or may not have looked at before is outliers. So an outlier is a value or values that are far outside the range of most of the data. Now there's an actual calculation for how to determine if something really is an outlier or not that we're not going to be doing right now, but just know that there is actually a quantifiable calculation for that as well. So they give me this data and they say they want to find the measures of center for this data, and this represents people who attended a movie theater over a period of 16 days. So I should have 16 pieces of data, which means n is 16. And you'll see that on your calculator sometime when you're calculating or on a spreadsheet. That means the number of data values. So to find the measures of center, at some point I need to put this data in order to find the median. So I usually put it in order first. Now when I put it in order, I don't cross off the pieces of data as I go through them, because then sometimes I can't read them. And I'm going to talk to you about how to double check your sum here in just a minute. So instead of crossing them off, I underline them, or if I have a highlighter, I highlight them as I go. So my smallest value is a 7. I'm just going to underline that I've already seen that, and there's a 10 and two 14s. Now, I already put this in order previously just to speed this up, so I didn't do it quite this quickly when I was putting them in order in the first place. There's a 20 and 3 different 21s. So my 20 and my 3 21s, there's my 3 21s and my 20. And then there's a 23 and a 26. So 23 and 26. After that, I have a 30 and a 32. So 30 and 32. Then I have a 35 and a 38. So far these are all not really close together. Obviously 7 and 38 aren't all that close, but it's sort of, there's a pattern and it goes, and then all of a sudden, boom, we skip all the way up to 80 and then 92. So I'm looking and I'm saying 80 and 92 are outliers. They aren't close to any of the other data. Yeah, 7's kind of small, but 10 isn't all that far away from it, and then 14's not all that far away from 10, etc. But I have this huge gap between my 38 and then my 80 and 92. So I need to find the mean, and you do need to tell me which thing you're finding, because if you find all three but you don't label what they are, I don't know if you know which one's which. So to find the mean, I need to take the sum of this data, so add all the numbers together, and then divide it by 16 because there are 16 things. Now this is a sigma, and it's a Greek letter, but a sigma, again, sometimes you'll see this on a spreadsheet or on your calculator, it means a sum. So when I add these numbers together, the reason I didn't cross them off up here, I add them together after I had put them in order. And when I do that, I get 484. But then I go back and I add them together in this order to make sure I get 484 again. I knew that there were 16 pieces of data because it told me this. If I didn't, I would count how many things I have here and get 16. And I would count how many I have here and get 16. If I make sure that 16 things become 16 things, I make sure I didn't lose a number. And then if I add them together here in order and then go back and add them together in here when they weren't in order and I get the same sum, it should mean that I didn't miscopy anything. One of the biggest reasons why people miss problems is not because they don't know what they're doing on this, it's because they don't copy the data correctly when they put it in order. So taking that just a couple minutes to make sure that you did it right is helpful. So to find the mean, I need to show this work. I'm going to take 484 and divide it by 16. Now in this case, my mean is exactly 30.25. So I can write out that entire decimal because it's exactly 30.25, and that's what I would like for you to do. My median, the reason we had to put the data in order is to find the median, And the median is the middle value after the data is put in order. Now again, I do not cross off numbers when I go. Some people go cross this one off to get to the middle. I want to still be able to see this data. So if you need to, you can do 1, 2, 1, 2 things here, 2 more things here, 2 more things here. So put a mark underneath them, but don't cross them off. 2 more here, 2 more here. I'm going to go down to 1 because we're getting close. And I find that I have these 2 values in the middle, which I already knew was going to happen. If there are 16 pieces of data, there should be 8 on one side of the median and 8 on the other side. So in this case, when there's not an odd amount of data, there's not this number sitting in the middle by itself, to find the median, I have to average these 2 middle numbers together. So I'm going to take 21 plus 23 and then divide that by 2. If you put this in your calculator, put 21 plus 23 equals, and then divide by 2. Otherwise, if you put 21 plus 23 divided by 2, your calculator knows the order of operations. It's going to divide the 23 by 2 and then add it to the 21, and that's not what you want it to do. So I end up with 44 divided by 2, so my median is 22. If you have to average 2 middle numbers together, you have to show that work. Now, if this was 21 on the left and 21 on the right, and it was exactly the same number, you don't have to show me that you're averaging 21 and 21 to get 21. But if these numbers are different, you have to average them. You need to show me that work. Now, the mode is the value or values that appear most often, not anything that appears more than once. So yes, 14 appears more than once, but it only appears twice. 21 appears 3 times. Nothing else appears 3 times, so 21. And one thing I forgot to do, we actually know what this data means. This is the number of people who attended, so this many people should be each of my answers. So 21 people. Sometimes it's just data and I don't know what it stands for. In this case I do, so I need to make sure I put those labels. Now, they want to compare their attendance to that of the other theaters in the area. Which measure best represents the data? Well, in this case, the median and the mode are very close to each other, so either one of them could be used. So either the median or the mode. And I really should have typed this. Either the median or the mode best represents the data. Now, they didn't ask me to write out why, so I'm not going to write it out, but I want to explain why I say that. It best represents the data because if you look at these numbers, 30.25 is way over here to the right. And the reason that that mean is pulled out of whack is because we have these 2 outliers on that side that really pull that farther to the right than it should be. The 21 and the 22 are actually kind of right in the middle of the data. So it depends on what the manager wants to do. If he wants to kind of bragging rights to say, hey, I have a lot of people that come to this theater, he's going to want to use the mean. But if he truly wants to get a feel for how many people on a real average day come to the theater, it's 21 or 22 people. So it depends on what he wants to use the data for. Now, something else that's new maybe this year for you is the 5-number summary. The median you're used to finding, that's the same median you just found a little bit ago. Minimum is the smallest value in the data. The maximum is the largest value in the data. And then these quartiles. The median is actually the second quartile. Means when you divide your data, instead of up in half, and the median's the middle number, the first quartile is the median of the lower half of the data. The third quartile is the median of the upper half of the data. So these 3 middle things are all medians, in a way. Now, it wanted me to find the 5-number summary of the data set, so I just recopied it to make it easier to use. And here's what I usually do. I know that my median was between these 2, so I can evenly divide that data in half. Now, my minimum is that smallest value after I put it in order, which is 7. My maximum is that largest value after I put it in order, which is 92. My median, I'm not going to show the work for here only because I already showed the work for it. If it just gave me this and wanted me to find the 5-number summary, I would need to show the work for the median. But since it's already on my paper for that problem, I'm not going to do the work again. Now, there were 16 pieces of data, so there are 8 pieces here on the left. Divided evenly in half, this data is. So if there are 8 pieces on the left, it means there are 4 on either side of the first quartile. 4 here, 4 here. So the first quartile is the average of 14 and 20. So this Q for quartile, a little subscript of 1, meaning the first quartile. And I have to take 14 plus 20 divided by 2. Again, if you're putting this in this calculator, 14 plus 20 equals, divided by 2. So the first quartile is 17. The third quartile, also called the upper quartile, and the first quartile is called the lower quartile. There are 8 pieces of data here to the right of the median, so it would be right between these two, the fourth and the fifth ones. I'm going to take 32 plus 35 and divide it by 2, which is 77 divided by 2. So the third quartile ends up being 33.5 people, 33.5. Now, I didn't put my labels on these as people because when you actually write out the 5-number summary, you just list these in order with no labels on them. 7, 17, 22, 33.5, and 92. That is the 5-number summary, and it has to be written in that order because somebody looking at this and knowing it's the 5-number summary can immediately go in and say, oh, the third quartile is 33.5. The minimum is 7 because it's written in the correct order. Now this says before class, but I actually want to work